This is Mr. Anderson from Keller Community College. This is part 2 of section 7.3, or the multiplying radical expressions in the Intermediate Algebra Math 121 book. We're going to start off with doing some more simplification, and it might be a good idea to list common roots of squares and cubes. So for example, here off to the side, you may want to write down a couple numbers that are easily rootable. So for the squares, the easily rootable numbers are 4, 9, 16, 25, 36, 49, 64, 81, and 100. And then the commonly rootable cubic numbers would be 8, 27, let's see here, 64, 125, 216. And we'll put up some x to the fourths and x to the fifths in case we need them. Now, we're going to first start off with a cubic root. This is a negative 27, so we notice that that's one of our numbers over here. But what's interesting about that is we can actually have the negative 27 under the cubic root if we wish. Now, this x to the fourth, let's make that into x cubed and x. You'll notice that we can split these up using our product rule from the previous section of notes, but you'll notice here that this x cubed and x make x to the fourth. So let's go break the things we can apart. The cubic root of negative 27 is going to be negative 3. And the cubic root of x cubed is just going to be x. Now this cannot be broken down any further because this power is too low to remove. So this is going to be the cubic root of x. So that is your final answer to that problem. In problem 10, before you look at this trinomial and say, oh, I give up, well, first try factoring out a 2 inside the radical. So we're still inside the radical here, and we're going to factor out a 2, so this becomes x squared plus 4x plus 4. Now what's nice about that is that still under the radical here, we have this x squared plus 4x plus 4, which is the same way of saying x plus 2, x plus 2. The two numbers that multiply to make 4 and add to make 4 are 2 and 2. Well, let's keep going here. This is going to be 2 multiplied by x plus 2 quantity squared. And since we can break this up into the square root of 2 and the square root of x plus 2 quantity squared, the square root of something squared will be itself. So that means that our x plus 2 quantity squared in the square root is just going to be x plus 2. And the square root of 2 is going to be trapped inside the radical. So this is our answer to the problem. X plus 2 times the quantity of square root of 2. Now, dealing with these radicals, I'm going to kind of show you in problem 11 and 12. I'm going to show you like the short way and the long way, but start out with the long way first. X to the sixth is the same thing as writing x cubed times x cubed, because you add the exponents to get to x to the sixth. And because of the product rule, I can break these into the cubic roots times these x's. That's going to leave me with x times x. I can do the same thing with the y's. I can take this y to the seventh and write it y cubed. And I can write this y cubed. And then I can write this y, because I need 3 plus 3 plus 1 to make 7. Now every group of 3 is going to turn into 1y simplified, and this, unfortunately, this cubic root of y is just going to stay unsimplified because it was too small to get out of a cube root. Now you can see where this is going to get rather long and involved, because the z to the 13th is a lot of 3's. I can write z to the 13th like z cubed times z cubed times z cubed times z cubed times z, because there are now a total of 13 of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Well, if I take all of these, I'll have my little check marks, cubic roots, still in the cubic roots, and finally the last cubic root. So this all makes 1, 2, 3, 4 of my z's, 1, 2, 3, 4 z's, and I have a cubic root of z that can't be removed. So my final answer here is going to be putting all of my x, y's, and z's together. So this is 2 of my x's, 2 y's, and 4 z's, or x squared y squared z to the 4th, times the cubic root of y and z. And I can put those together because those are still trapped inside the cubic root. So that's the answer to number 11, but it sure took a long time, didn't it? Writing out all of my breaking up the product rules. So there's got to be a faster way. And there is. Take a look at number 12. You can ask yourself, how many times does x to the 4 fit into x to the 5? Well, there is unfortunately not enough x's to break out of this 5, so my radical to the 5th power still has contained 4 of my x's here. Now here you'll notice that I have 5 y's and this is y to the 5th, so that means 1 y gets out because 5 divided by 5 is 1 with no left over. You'll also notice that this is 6. This 6 is greater than 5, so that means I have 1 remove, which is 5 of my 6 z's, but I have 1 z left over. So this is my final answer. My final answer is yz and the 5th root of x to the 4th z. So you need a number bigger than the index to get out, and the number on the inside will be how many left over. So taking another example off the side here, what if I had the 3rd root of x to the 10, y to the 11, and z to the 12? Well, how many, if there are 10 here, 10 divided by 3 is 3, so that means 3 gets out, but I have 1 left over, so that means I'd have 1x inside here. How many times, if I go y divided by 3, that would leave me with 3 that gets out, but I'd have 2 left over. And the 12 would be 4 z's that get out, because 12 divided by 3 is 4, with none left over. So my answer would be x cubed, y cubed, z to the 4th, with the cubic root of xy squared. So a way to think of it is think about your multiples when doing your division work here. Alright, moving on to number 13. Now I like to handle my numbers separately from my variables. So I'm going to take a look at the square root chart and see if one of these numbers can divide into 128. Now make sure to go big. Don't use 4 or 16. Isn't there a bigger number that can divide 128 evenly? And there is. It's 64. So this is going to be the square root of 64 times the square root of 2. And now let's handle that in just a bit here. Let's break these up here. Now 7 can be divided by 2. And 7 can divide 2 3 times with 1 left over. So this is going to be x cubed. And I'm going to have the square root of x. Because this would be 6 plus 1 to make 7. Now if I see, okay, well I got y cubed here, so it looks like I can take the y out once. And I'll have 1 y left over. So this is going to be y square root of y. And let's see, z to the 10th here, I can take out 5 of them because 10 divided by 2 is 5, so this is z to the 5th power. And now I'm just going to put everything together that, since I'm going to put everything together that can break out of a square root, like the square root of 64 is 8. So 8, I've got an x cubed, and I have a y and a z to the 5th. So all of these terms, this one here that I'm circling, this one here that I'm circling, this one here, and this one here, these all get taken out. Now I'm looking at all the square roots. So I have the square root of 2xy. And there it is. Now let's look at problem number 14. Now taking a look at my cube root chart, can you see something that maybe 250 can get removed? Like what number evenly divides 250 easily? Well, that 125 can do the trick there. So I'm going to remove a cubic root of negative 125, since I can remove cubic roots of negative numbers. This will leave me a cubic root of 2, because these two multiply to make 250. Now, unfortunately, that x squared isn't big enough to get out of a cube root, So that x squared is going to remain trapped inside of the cubic root. But the 9 squared is big enough to get out of a cube root, and 9 divided by 3 is 3. So this is 9 to the, or y to the third power. Now 16 doesn't evenly divide by 3, but it will. But 15 will evenly divide 3. So there's there's a 5 there, but there's 1 left over. So I'm left with inside a cube root a z. So now what I'm going to do is, simplify my numbers if I can, and I can do that because I have the cubic root of negative 125, which is negative 5. And let's see. So there's that. And y cubed, that got out, so I'm going to put that there. Z to the 5th, I'm going to put that there. And now I just take the entire cube root here. This is going to be 2x squared z. Alright, for the bottom half here, let's do these 6 problems together. We're going to multiply and simplify. So what's going to be kind of cool about this is that we can actually do more once we put the problem together than what we had at the start. So for example, square root of 2 is square root of 6. Can't really do anything with that. But what's nice is when you put these together and multiply them to make the square root of 12, because 2 times 6 makes 12, because they're both under the same radical power, you can actually simplify this, because this can be factored into the square root of 4 times the square root of 3. And the square root of 4 is rootable, so 2 square roots of 3. Same thing here. The cubic root of 2 and the cubic root of 4 are, you can't do anything with them. But if you multiply those together, now you have the cubic root of 8. And the cubic root of 8, according to your chart, that is now off the screen, but could be on your paper, is 2. Okay, looking at this one here, multiplying these together under the cubic roots, we've got 21x cubed. Now, unfortunately, there's no cubic root that can easily divide 21, because 8 is not going to divide 21, nor is the next biggest number, which is unfortunately bigger than 21. It's 27. But you can notice that I can take the cubic root of 21 and split the cubic root of x cubed away from it. So this simplifies to 1x, because x to the 3/3 is 1. And then this here is the cubic root of 21. That's your answer. And we will always put the numbers that escape from the cubic roots in front of them. Okay, here, we're going to put this all under the same cubic root, since we can do that. This is x to the 4th power and y to the 10th power. And this gives us a very good time to kind of look at how we can break this up. 4 cannot divide evenly into 3, but 3 3s can, so that will leave me with 1x removed and an x under the radical. See, this would be 3 plus 1, which makes 4. Now, 10 can't divide 3 evenly, but 9 can. 9 divided by 3 is 3, so this is y cubed, and that leaves me with 1y left in the radical to make my 10. So there's my answer for problem number 18. Okay, problem number 19. 5 and 15 make a total of 75, so if I multiply these together, 75x to the 10th power. Then what we'll do is split these apart. We'll split these apart because 25 can go into 75, and 25 is a square rootable number, which leaves me with 3. 25 times 3 is 75. And then I have the square root of x to the 10th. What's nice about x to the 10th is that is completely rootable, because with this index of 2, this gives me 10 divided by 2, which is 5. So this here makes a whole number 5, and this here makes the x to the 5th power. 10 divided by 2 is 5. And then we have square roots of 3 right there. Okay, finally problem number 20 here. That will end our little work session. We're going to multiply all these together under the 4th power here. So 9 times 9 is 81. Sorry about that. Nothing was writing there. 9 times 9 is 81. X to the 7th and x squared is x to the 9th power. Y to the 2nd and y to the 9th is y to the 11th power, which means that now we get to play with this removing the 4th here. Now, the 4th root of 81, that's going to be a whole number 3. But now we have to think about like the 4th root of x to the 9th. Now, 9 cannot divide 4 evenly, but 8 can. So that leaves me with x squared with an x underneath the 4th root radical here. Now, y to the 11th under the fourth root, that y to the 11th, 11 cannot divide 4 evenly, but 8 can. So 8 divided by 4 gives me 2, and that also leaves me with 3 left here, because 8 and 11 is 3 away, so that gives me y cubed. And this, again, the only last part of the problem I didn't process is this fourth root of 81, which gives me a positive 3. All right, well, thanks for watching, and email me if you have any questions.